Hey, Tom Penalized Math Industry, and we're going to be starting literal equations. So in this video, we're going to be solving an algebraic equation with algebra, and we're going to also use algebra to solve a literal equation, because you both use the same method to solve them, but the literal equation will have a different answer and a different way of doing it. So, we have two equations. Here's our algebraic equation with numbers in it, and a strange literal equation, but with letters in them. These will have two different ways of doing it, but you solve them the same way. So let's start solving the algebraic equation. So, we have an equation and a phase. Right here is going to be our given phase, because this is literally telling us that we have to solve it, and it's giving us the problem. Our phase will tell us how we solve it, and will explain all the steps. For example, positive 5, we're going to do a minus that by 5, and minus this by 5. That is called the subtraction property of equality. And now we have 5x equals 100. Then we get to simplify, which we just did, and we can do DPE to get that variable alone. So we divide this by 5 and divide that by 5. X is going to be 20. So for this example, x is going to become 20. This is what happens when numbers are inserted into an equation. But with the literal equations, but they don't have any numbers in them. We are going to still solve for x, but how do we do it? We're going to be using the same method. So this is our given phase. Then we have to have that positive b turn it into a negative b. But we have to minus that by b as well. And when we do SPE, which we just did, we gotta simplify, but our equation's gonna look different because B and C are totally different variables. It's not like you can have apples and apples, like A plus A is gonna be 2A, and X plus X is 2X. But if you do B plus C or B minus C, you can't really do anything because they're different variables. So, we're gonna have an equation that strangely is gonna look like AX is gonna equal to C minus B, because we have nothing inserted in the equation. After that, we want A to move, because X has to be alone. What is X? So we're gonna use DPE, and then we're gonna simplify and see what happens. So we're gonna divide this by A, so we have x alone on this side, and divide this by A. And when we simplify, we get an equation and an answer as x equals C minus B divided by A, which we can't really do because they're all different variables. This is our most simplest form. And what we just did is get x alone. So, with algebraic equations with numbers inside them, you can understand and get an answer of what x is, like x equals a number. But with literal equations, you can't really do that. When you're simplifying, you're not actually doing C minus B to get an answer. You can't really simplify, really. You're just writing the equation in a different way of thinking it. And when you isolate your variable that you want to understand what you want to target, like we wanted to isolate the x, we're gonna have all the same variables, but in a different way of saying it, because this way is the same as our given equation. So literal equations are basically solving it, but having to find a different way of thinking it. So now we know how to understand and solve literal equations. What we're going to be doing next is very, very cool. We're going to use literal equations to try and solve this question that was solved in 1983 by a mathematician named Terence Tao.